We have Kevin over here who's going to talk to us about network tapping technologies. This was an interesting talk going through. We're getting more and more requests for network analysis, and our networks are growing larger and larger, and there's no longer, oh, this one pinch point we can monitor. So let's see what we're going to learn today about that. Thank you.
Hi. So my name's Kevin Nassery, and this talk is called Network Tapping Technologies, and that was after a lot of working with the program committee, because the actual terminology that the industry uses is really inconsistent. A lot of people are using the term data access networks. I think if somebody had a much better name for this stuff, like firewall or load balancer, and it was real clear, it would be, giving this talk would be a lot less necessary, because it would be much better marketing for them. But alas, nobody's got a clever idea of what or a clever name for what they're working on. But in general, I'm just going to be talking about, there's a lot of changes from, 10 years ago using taps and span ports, and that stuff didn't scale real well with a lot of the new network topologies, and a lot of, just the advances in, high-speed networking was following basically Moore's law, but the Schmidt taps and stuff like that just, weren't scalable for the number of uses. So. So they were painful to deploy, limitations of span or, any port mirroring technology. A lot of that's come a little bit of ways within our networks in terms of in-band using, VACLs or something like that. But a lot of it isn't really doable within, inline network devices. DAN switches, that's what I tend to call them. I haven't mentioned any kind of vendors on the stuff. There are multiple vendors. Gigamon is a big one. Appcon, VSS, Anu. They're all kind of making the same types of things, and they're all kind of competing against each other. And part of the reason I wanted to give these talks is I think they're kind of competing against each other for the wrong things. I mean, they're spending a lot of time on user interface and stuff like that, which is maybe less important than some of the features we need to actually be able to use these things once they're configured. This is just kind of a general anatomy of data access network in general. You might have different kinds of sources from all over your network. You might have a port mirror or something like that as a data source. You might have an old school tap. You might have, a 10 gig passive optical tap or something like that. So however you get that, network telescopes or even binary traffic log data that you might be TCP replaying into a suite of tools or something like that, is potential from sources. So you have all these different sources and all these different tools and analyzers. And how do you get the right data to the right tool? From a security perspective, maybe you have, you want to prevent any financials data from going to your IDS sensors or something like that. Before this, tackling that problem was almost impossible. So what the DAN switching layers in these actual devices do, hopefully what they do, and some of what we'll talk about is kind of what they do well and what they don't. But having that inbound filter is a big thing. So if I'm looking at a link and I want to produce a feed to a tool that's only one customer data, being able to say, okay, I want to look at this link, this edge link or something like that, but only give me the destination addresses of a DMZ in my network or something I'm particularly interested in. After I do that, the biggest thing is aggregation. And this is something that we had at a physical layer with the net optics and stuff like that with aggregators and regeneration. But up until this kind of suite of products came out, we didn't really have a great way to combine feeds intelligently using something similar to maybe TCP dump, or not TCP dump, but something similar to aggregation after we've done the filtering. So once we have that kind of in-ground, we have a filtered inbound feed, and we have maybe multiple feeds aggregated together to produce a data source. Well, I might have two tools that still need discrete differences. I might have one tool that's a web application performance analyzer that I should then add an outbound field to HTTP. But I might have a different tool that's an IDS sensor or something like that where I want the whole feed. So being able to also egress filter on the way out is important. And output distribution mapping, so that just after the egress filtering, being able to actually route the right feeds to the right ports. And from an architectural perspective, after that comes your tools and analyzers, traffic logging, storage, IDS sensors, DLP, maybe you have a passive flow generation tool, or just somebody pulling up with a protocol analyzer and wanting to see events. And there might even be a higher layer after that, event correlation or something like that on top. So kind of the application layer extends into that. So I have just this example network. This is to kind of demonstrate some of the limitations of doing it the way we would do it 5 years ago, or the way we would do it if we didn't have any money now. And looking at this, maybe an e-commerce module or a small DMZ module or something like that. We have edge router layer. We might have edge routers and then edge switches, and traditionally we would do it like this in terms of if we had a passive flow generation tool as one of the protocol analyzers, that flow generation would probably need a span port off of each switch. And then even beyond that, it would have to have some way to aggregate that data together. So if you're doing this with a BSD operating system or something like that, you might even have to create some sort of virtual interface using Ethernet aggregation so that we can run one TCP dump or one snort session or one pflow generator on a single interface so that we have the full data flow or something there. And we might, we also probably want, IDS or something like that on an e-commerce network or a DMZ situation. So that kind of, and traditionally that might, pun intended here, that might tap you out in terms of the number of span sessions you can run, unless you're getting into something more advanced or unless you have a good platform that provides more port mirroring sessions. But VACLs can do it, but they also do a lot of nasty active things. So from a configuration perspective, people are generally a little bit less anxious to approve those change control tickets of making VACL changes, if they know what they are. The one discrepancy in this diagram is obviously this network engineer rolling up with the protocol analyzer here wearing the beige suit. I've never seen a network engineer in a beige suit. But where does he plug in if he needs visibility into that data? He might have to disconnect one of the active applications, and even if he did that, if he's got one interface on his laptop, how is he getting data visibility into both sides of a load balanced topology there? He really doesn't have that opportunity, so he might be seeing just half the pictures of the problem or whatever's going on. So how do we improve that? Well, it's really easy with DAN switches in this case. I mean, we would take the full span session from each individual switch, aggregate it together with whatever filtering is appropriate, and then we could just have 3 output ports, one going to your flow generator 2, one going to your IDS sensor, and a hot port where somebody can walk up and plug in and see all the right data. So you're reducing the switch port counts in terms of, and then you always have that. If he wants to get the data directly off the switch, you might have some available bandwidth there to create a second span session if you're looking at something where you really want to reduce, maybe some type of frame error or hardware error where you really want to see what's coming off of the switch. Use case 2, you're doing this on the core or something like that, and you want to provide system administrators with a feed of applicable traffic logs or out-of-band traffic logs. Well, you can't give them a span port right off the switch because that's going to have everybody's data in it. So you may want to have a customer situation where you create a filtered point that just has their data in it and provide that. So that's kind of the application of combined application where you're you're aggregating and doing it much more intelligently, plus the benefit of filtering in there. So yeah, with DANs, you'd be able to just aggregate that, apply the right filters, using something similar to, an IP ACL in order to get the right traffic to the right teams. And the NetEng team might have a full feed. The team, your server guys for one group might have, the Windows group might have one feed, and the Unix guys might have another. So that, in the old school way, is pretty much impossible to do. Just how I got into this stuff, I used to work for an enterprise where we started using these things, and I went into security consulting with a focus on kind of network security architecture, which for most organizations, they have awesome network teams and awesome security teams that kind of act like a divorced couple. And like my job is to try to mediate and get them to do the same thing in one kind of coherent way, where usually it's like, okay, the network team, puts together the Jenga game, and the security team comes and removes blocks until you have something that's about to fall over. So my goal is to kind of build the most stable structure from the get-go. I recently kind of was an advisor on an effort where, a large organization had potentially, multi-aggregated 10 gig links coming in, but they wanted, flow-based forensic accounting for, incident response and stuff like that. So they didn't want to use their actual hardware was using, S-flow sampling, where they could, statistically, from a security perspective, you want to see every frame, where from, S-flow, you might be looking at 1 in every 32 frames or something like that, or even, by default, up to 1 in 2048 frames, and generating your records there. You might want, as true as you can keep up with the speed, full forensic logging there. So we went through all this, and we saw a whole bunch of versions, and we released, based on us seeing a lot of product, we released an RFP that'll kind of cover it, and we didn't see a lot of great response. So that's kind of my motivation for giving this talk, is to try to unite you guys as consumers to have a coherent message where we want to focus on getting some of these features in there to make it more useful across the board. For the most part, we saw a lot of differences in how we configure devices, not so much differences in capability. So first, these things to me are a huge improvement over stuff we've seen, and I was blown away, when I started using them, the new things we could do versus, the nastiness of even generators or regenerators and aggregation stuff. So the flexibility is great. Performance advantages, you can limit tools so that they're only seeing the data they need to see. I've seen a lot of tools get knocked over because they have to throw away data that they don't care about, and they can't keep up with that. It avoids any complexity with using distributed sniffers or RSpan. Obviously, you kind of deploy a device near where your links are. It doesn't necessarily span geographically topos where you have ports from different environments. So that part of distributed sniffers isn't replicated. But you can do a lot of things to be effective here. They're easy to use and pretty much managed remotely. They put a lot of work into maturing most of the interfaces. They aggregate multiple sources, filter the input data, and distribute that input data out. So all the things we talked about, great. What's one of the bad things? Well, so I have this awesome device between my sources and my destination, but if I'm only interested in maybe flow, looking at headers, or maybe generating flows and link analysis, I don't need a lot of that payload, and in fact, I might not want a lot of the payload from maybe that security perspective of, okay, this person is doing a network accounting effort or a link utilization effort. He doesn't need to be seeing credit card transactions or something like that, on back-end servers. So wouldn't it be cool if this, in addition to doing everything that it does, this box in there could truncate frames? And obviously, there's a performance improvement too, depending on your application and how much processing power you're spending per frame or whatever. But from a tool, from just the bandwidth perspective, you really only need 5% of a fully saturated link in order to do that accounting. So you might be able to scale your tools, more effectively if you're just discarding that payload data out of the situation. The second thing is that, so they have these filters, and they have a lot. You're basically, at this point, kind of limited to the filters they provide to you. So they might provide you a suite where you could say, hey, I want TCP port 25, or I want, the basic core IP core protocol header information. Where if you're using, anything like we were looking at before with the RBIS stuff, where you have protocol offsets that might not be compatible with what they're giving you to, there's no way to really produce. They do provide you, in some cases, a start of frame offset, but depending if you're, even frame tagging or something like that, it's going to be real variable. You can't say, I want, the first byte of a TCP frame. You have to say, okay, I want offset 64 bytes into that frame or whatever kind. And that, to me, is terribly not useful. I mean, there's a lot of stuff you can do with the TCP stuff, but I want a simple, flexible way to say, hey, I want 4 bytes into a TCP frame, not have to calculate for every media type that I have what that would be and run different filters and try to create something going on like that. Or the difference between IPv4 and IPv6, you're always writing 2 filters to try to get the beginning of some type of PDU. The other thing that tends to happen with this, I've seen a lot of span ports. So if you, for example, if you have like a VMware host that's trunked to a switch, and you take a span session of that, when hosts are talking to each other on that same VMware host but getting routed through the network, when you capture that data and you send it to the span, a lot of times span ports are stripping out the .1Q frame tags. So it looks like you have duplicated packets. It's really hard to tell what is coming out of one host and into the other because the frame headers were torn off by just the port mirroring hardware solution that was in place. So, and the other time you see this a lot is where, if you have multiple tiers of network, you're aggregating ports from both your edge layer and your distribution layer into the same tool. Again, you have that duplicity there where it's like, okay, this packet was not a retransmit, which maybe my tool thinks it is. This packet was seen at 2 different places on the network, and either I wasn't using .1Q headers at all, or my mirroring ports are stripping it out. So that's really pretty. It definitely is cramping what you can do on the architectural side of using these things. So when it does strip that out, the one option you do have if your thing is stripping that out is most of these things also provide very good hardware for getting in line. Either passive optical taps for 10 gig, your old school 100 megabit Ethernet taps, and even for like gigabit Ethernet instead of doing taps which are slightly more complex to do electrically with gigabit Ethernet. You can basically create a path through the device of 2 ports, cable through it, and then it uses that. It not only does it forward the traffic back and forth on those ports so the link still works, but it also uses that as a source virtual interface for whatever you're doing on the back end. So that's pretty useful because obviously gigabit is pretty much everywhere, and it's not that easy to tap. On copper, it's not that easy to tap. And we kind of talked about this before. Source ports must be from a single network layer in terms of seeing that same duplicity. So, and thinking about this and looking at these RFPs, I kind of have like 6 things that I think is a good starting point to get some of the functionality back without making drastic changes to how these devices work. The first thing is it should be pretty easy for people to implement inline frame truncation. And this is the only thing, in the process that I've ever heard rumors of being like, okay, we're working on this, and yeah, we're working on this, and it'll be coming soon. So that's good news. The second thing is definitely we want TCP dump style frame offsets. I want to be able to, for very common PDU offsets for our IP core protocols, TCP and UDP, I wanted to be able to say, okay, 3 bytes into the UDP versus 110 bytes off of the starter frame for some particular media type. It would be really nice if switching vendors in cooperation with all this, especially people who make both devices, if they really made an effort so that if a source data port is frame tagged, to either retag it on the way out the way it was tagged on the way in, or figure out a way to preserve that .1Q tab so you're not resorted to using some type of nasty tab solution where you don't need it. In terms of resolving the other issue where you're seeing at multiple layers of a path the same packet data, perhaps some sort of IPTTL deduplication where it's like, okay, this packet is the exact same thing except it's been routed over a hop somewhere, and it's got a different TTL, and maybe have some sort of topology way where thing to use in certain situations. The other option of tackling that, which I kind of thought after a while it seems to solve a lot of these problems, is being able on an input filter to create an artificial .1Q tag on that input, so when it goes out to the tool, I could label something as, okay, VLAN 40 as it comes in, even if it wasn't ever tagged and it's not part of my inline topology for it to ever have that VLAN tag. And that way on the tool side, I can say, okay, watch this link and VLAN 40 and whatever else you were supposed to do in order to reduce the, that problem of, okay, this tool sees this packet at 4 different points. Well, it only saw it once with VLAN 40 tag coming in off this network layer. So being able to kind of, artificially frame tag input stuff based on particular filters would be incredibly valuable. And the last thing is, I mean, SFlow works for a lot of different, in JFlow, any statistical sampling for a lot of these protocol analyzer applications, if they're, not security, if they don't have that security dependence of being able to see every frame statistical sampling is a great way to reduce, utilization from your analyzer resources. So that's pretty much all I came here to talk about. If anybody has any questions or anything like that.
Thank you, Kevin. Anyone want to talk about data access networks, experiences with packet capture, similar issues that they've run across, ways they've solved it, ways they wish they could have solved it if products like this existed, products like this they've used that they like, don't like? Kevin?
Kevin Oberman from ESNet.
Hi.
First of all, I want to echo your comments on what's wrong, particularly the truncation issue is something that would be immensely useful. The value of this sort of thing for security is really, really great. Unfortunately, the term, once again, is, as you mentioned earlier, data access networks is one that most people aren't familiar with. And in fact, when I researched it, I could only find one company out there that was selling a product that actually used this name.
I found two, which made it the most common term.
Well, two, that is more common. But it's really a very useful technology, or could be a very useful technology. But at least in many cases, the fact that you can't do truncation makes it impractical to use. So of all the things that need to be done, if they could implement truncation, that would make it really, really useful in ways that it just simply can't be right now. Because if you've got a high volume link and you have to basically send all the traffic out another port, well, you just filled up 2 ports, and that gets really expensive.
Yeah, absolutely. And one of the great tools to combine with this technology, if your budget permits, is some of the new hardware capture cards that can do TCP style acceleration on the card, where you can throw away a lot of data real quick and ASICs on a dedicated capture card. It makes this stuff a lot more valuable than just using aggregation together, because you then have the physical capability to do a lot of line speed operations on the data you're getting, which you might not be able to do because you've got too much payload getting in the way. And thanks, Kevin, for your help on this presentation.
So that it? Okay, great. Well, thank
All
you
right,
so
thanks,
much.
everyone.
We'll appreciate that.